Hello and welcome to Mathematics with Simon. I'm Simon. So today we're going to look at another Mathematical Olympiad question. We did one yesterday, it was so much fun. So we want to show that this number is rational. That's the problem that we're set. And it's amazing that this would be rational, or how we would prove that. So the first step is we're going to introduce some notation. Notation is very helpful and powerful in maths. So we're going to assume that we're going to define alpha as the cube root of 2 plus root 5. We're going to define beta as the cube root of 2 minus root 5. That allows us to write x equals alpha plus beta, which is handy. We also notice that alpha times beta is the cube root of 2 plus root 5 times 2 minus root 5, which is the cube root of minus 1, because it's the cube root of 4 minus 5, cube root of minus 1, so it's minus 1. Alpha times beta is minus 1. That's really helpful. Next thing we're going to do is to cube this expression, and the reason we're going to cube it is because it has some cube roots in it. So maybe when we cube it, some of those terms will simplify. So the front term and the back term are cubes of cube roots, and so they're going to simplify. So x cubed equals alpha cubed plus 3 alpha squared beta plus 3 alpha beta squared plus beta cubed by the binomial theorem. The front term simplifies to 2 plus root 5, the back one to 2 minus root 5. They then just add to 4, which is really helpful. We then notice the next two terms involve alpha beta, which is minus 1. So we get minus 3 alpha minus 3 beta, which is the same as minus 3x, because x equals alpha plus beta. So x cubed plus 3x minus 4 equals 0. So now we have an equation for x. We notice that x equals 1 is a simple solution to this equation. You put in 1, you get 1 plus 3 minus 4 is 0. That's correct. We can then find the quadratic factor that we multiply by x minus 1 to give us x cubed plus 3x minus 4. The quadratic factor, you can do this by polynomial division. We've got a video on that. But also, actually, you can just do it in your head, because basically, you need a constant that you multiply by minus 1 to give you minus 4. That must be plus 4. You need an x squared term that you multiply by x to give you x cubed. That must just be x squared. And then there's no x squareds on the left-hand side, so we've already picked up minus x squared from minus 1 times x squared. So we need a number to multiply by x that gives you plus x squared to cancel with the minus x squared, and that term has to be x. Then just check that you've got the right number of x's. So you've got 4 times x is 4x. Minus 1 times x gives you minus x, so you've got plus 3x, which is exactly right. So this is the correct factorization. You then notice that there are no real solutions to x squared plus x plus 4, because the discriminant is b squared minus 4ac, so it's 1 minus 16, so it's minus 15. So we assumed that x was real, so x must be 1. Can we believe it? X is 1. And I actually had to go and check this in Excel to make sure that it was right, which is a good thing to do. It's good to find different ways into things and to check things, because it helps you understand, helps us understand. And just to say, why did we assume that x is real? Well, we assume that these are the real cube roots. We assume they're working in the real number field. Although it wasn't explicitly stated, but you know, I think when it's not stated, you assume you're working in the reals, rationals, integers. So from this, we know that x equals 1. There was another way of coming at this. So if we start with x again as alpha plus beta, in the previous video we saw, and I'll put a link in the description, we saw that a cubed plus b cubed plus c cubed minus 3abc equals a plus b plus c times a squared plus b squared plus c squared minus ab minus ac minus bc. So if it were the case that a plus b plus c was 0, then a cubed plus b cubed plus c cubed minus 3abc would just be 0, which is really good to know. So here, x equals alpha plus beta, which means that x plus minus alpha plus minus beta is 0. So they can be our a, b, and c, which then tells us that x cubed plus minus alpha cubed plus minus beta cubed minus 3abc, which means minus 3x alpha beta, is 0. And when you work that out, you get alpha cubed is 2 plus root 5, beta cubed is 2 minus root 5, 3x alpha beta is minus 3x, and we're talking about minus 3abc, so it's got to be minus 3x, which is plus 3x. So then you end up with x cubed plus 3x minus 4 equals 0, the same equation as before, factorises the same way as before, and we get the solution x is 1. Wow, what fun. So I hope you like this. I liked making it. I had to record it 2 or 3 times because I kept making mistakes and it annoyed me, and so I kept wanting to get it right. Who knows? Sometimes mistakes are human, but sometimes they're annoying, and in mathematics we're in the business of truth. I'd love to hear your ideas. Most of all, I hope you enjoy your mathematics, and I'll see you next time.